video, we're going to talk about converting between radians and degrees. I've started a table up here. I've got an angle theta, okay? And here we're going to list its measure in degrees, and then we're going to convert that to radians. So we're going to start by going from degrees to radians. We will look at going the other way as well. That is necessary. Particularly in calculus, what very often happens is you might be given an application problem. And very often in the real world, people measure things in degrees. So you're given some angles in degrees. But then you want to do some calculus. Now, if you're in pre-calculus right now, you're not going to do that this semester. But you might be doing that next semester. So you convert things to radians to do the calculus. And then you convert back to degrees to answer the question in the same format where it was given. So it is necessary to be able to go in both directions. I've started here because I've just started with some angles that you're probably already very familiar with in degrees. These first angles are called quadrantal angles. That's because if I draw them in standard position, their terminal ray would end up on one of the axes. So 0 degrees, well, we start on the positive x-axis, we don't rotate, we're still on the positive x-axis. And it's called a quadrantal angle because the x-axis is the boundary between quadrants 1 and 4. 90 degrees in standard position would put me on the positive y-axis. That's the boundary between quadrants 1 and 2. Okay. Now, there are certainly more quadrantal angles than this because I could rotate more than 360 degrees, or I could rotate in the negative direction. So I've just put up the first 4 positive quadrantal angles and then 0. Okay. Now, at the end of the last video, we determined that 360 degrees, which was 1 full revolution, was 2 pi in radians. And remember, we don't write any units. Radians are a unitless unit. Okay, so I already have that one. I'm going to use that to figure out the other quadrantal angles. Because 180 degrees, well, that's just rotating halfway around. Half of 2 pi would be pi. I don't need to do any fancy calculation. I can just say, hey, that's an easy fraction of a full revolution. Okay, 90 degrees is half of 180 degrees. That's a quarter of a revolution, so I could think of it as a quarter of 2 pi or a half of pi. Either way, I'm going to get pi over 2. Okay. 0 degrees, that's maybe the easiest. If you don't rotate at all, you're going to be 0 no matter what unit you're using. So if I don't write any unit, it means 0 radians. If I write the degree, it means 0 degrees. It's the same angle either way. Okay. 270 degrees, that's just rotating to the negative y-axis. So that's rotating 3/4 of the way around. Okay. That's 3 of these. 270 is 3 times 90. In radians, it's 3 copies of pi over 2. Okay. So I didn't really need any fancy conversion formula. I just needed an understanding that a full revolution is just the circumference of the unit circle, so that's 2 pi, and then these are very nice fractions of that. Okay. These angles here, 30, 60, and 45 degrees, those are the acute angles. Acute just means between 0 and 90 degrees. Those are the acute angles that we work with the most often. Okay. And we can get those as well. Now, I could get those along the same way. I could say 30 degrees is a third of 90 degrees, so I could multiply this by a third. Okay. What I'm going to do instead is I'm going to show you a technique that works for any angle, because these angles do happen to be very nice fractions of a full revolution. 30 degrees, well, that would go into 360 degrees 12 times. So this is 1/12 of a full revolution. Okay, but I'm going to show you a way of converting from degrees to radians that works even if you don't have a nice fraction like that. Okay, so if I have 30 degrees, okay, what I'm going to do is I'm going to convert that to radians by multiplying by a fancy form of 1. Okay. Now, beautiful thing about 1, you can multiply by any form of 1. It does not change the value of things, but it can change the way it looks. I want to change the way this looks by keeping it the same amount of rotation, but changing from degrees to radians. And 1 is just anything that's not 0 over itself. So what I'm going to do is I'm going to look here. Now, I don't want to use this because that would be 0. Don't want to use 0. But I know, for example, that 360 degrees is 2 pi. So the fraction I could create, 360 degrees over 2 pi radians, or 2 pi radians over 360 degrees, both of those are just a fancy, weird-looking form of 1. Because it's the same quantity on top and bottom, it's just being measured in different units. Okay. Now, I could certainly use this. Usually what I'll use is this. 180 degrees, which is half of a revolution, is the same as pi radians. That's the first quadrantal angle I can use that doesn't involve fractions. Okay? So I kind of like that. So I know I'm going to create a fraction with 180 degrees on one part and pi radians on the other part. Okay, so then I just need to strategize. Now, it might help to write that 30 degrees over 1 so that it looks like a fraction. My goal is to get rid of the degrees. If I put the degrees in the bottom, the degrees will cancel. So I'm going to say 180 degrees, that's the same as pi. With no unit here, that means radians. The degrees cancel. I can cancel a factor of 10, and 3 goes into 18 6 times. I get pi over 6. Fabulous. Okay, I'm liking that. So, to go from degrees to radians, I'm essentially multiplying by pi radians over 180 degrees. I know when I was first taught this, I was just given that conversion formula, and oh, I am so bad at memorizing. I knew I either had to multiply by pi over 180 or 180 over pi, but it was so hard to remember which. Finally, somebody showed me, I want the degrees to cancel. So make them cancel. If they're already on top, put them on the bottom. Okay. That way, I understand which I'm putting on the top and which I'm putting on the bottom. Okay. All right, so let's do that with 60 degrees as well. So 60 degrees, I could write that as a fraction if I want to, just 60 degrees over 1. Now, here I don't mean over 1 radian. I just mean 60 degrees over, well, anytime I have something I can divide by 1 and it doesn't change the value. This is not 1 of anything. That just allows me to have a fraction so that I can see that the 60 degrees is on top. Again, if I want the degrees to cancel, I'm going to put 180 degrees on the bottom and pi on top. The degrees cancel. 60 goes into 180 3 times, and so I get pi over 3. So 60 degrees is pi over 3. Okay. One thing to be careful of, there's a 3 and a 6 in 30 and 60, and there's a 3 and a 6 in pi over 6 and pi over 3. The 3's don't go with the 3's and the 6's don't go with the 6's. That's because the bigger the denominator of a fraction, the smaller the angle. 30 degrees is definitely less than 60 degrees, so it's got to be the smaller fraction. It's got to be the one with the bigger denominator. Okay. All right, let's take a look at 45 degrees, and then we'll practice one where we go from radians to degrees instead. Okay. So if I have 45 degrees, I'm going to multiply that by 1. Again, if I want to put a 1, not 1 of anything, just the number 1 here so that I can clearly see that the 45 degrees is on top, that's allowed. I want to get rid of degrees, so I'll put 180 degrees here and pi radians on the top. The units cancel. 45 goes into 184 times, and so I get pi over 4. Now, this table that I have here may be something that you're already familiar with. If so, great. I do think these are angles that we use often enough that you want to have this information at your fingertips. But I do not recommend that you memorize it by like creating flashcards and trying to memorize it. Because anytime I memorize something, I'm really good at then forgetting that thing. Okay? And I'm really good at confusing things that I've memorized. What I recommend instead, and I recommend this a lot with Trig, is that you accidentally memorize this. And here's what I mean by that. You accidentally memorize it by, if you don't already have it memorized, you go through this work. You create the left side of this table once a day for the next week. And you figure out the right side of the table. With some of them, you might just do what we did with the quadrantal angles and say, oh, that's half of a revolution, so that's going to be half of 2 pi. With others, you might do this multiplication by this conversion factor. Okay? But work it out. Figure it out once a day. If you do that, eventually you're figuring it out and you're like, oh, 30 degrees. I know I'm going to get pi over 6. Okay, so you've accidentally memorized it. You remember what the result is supposed to be. But the beauty of accidental memorization is you memorized it by figuring out why it's true. So, if your accidental memorization should happen to be followed by an accidental forgetting, which is often a very common sequence of events, you know how to figure it out again, so you can get it back. Okay, so I strongly recommend that. And again, some of you may already have this memorized or accidentally memorized, so you've already got this information at your fingertips. Fabulous. Okay, let's just try doing one where we go from radians to degrees. It's the same basic process. Let's say I had pi over 12. Okay. Now, with no units written, if I'm told that that's an angle measure, I know that that's in radians. And that's already a fraction. The whole thing is radians, but I've already got this lovely fraction. So now I'm going to multiply by 1, but it's going to be a funny looking form of 1 because the top and bottom are going to be in different units. This time I'm not trying to get rid of degrees, I'm trying to introduce degrees. So I want the degrees to be on top. So I'm still going to work with this pair, but I'm going to put 180 degrees on top and pi radians on bottom. Okay. Now, it's a unitless units, but this was radians, this was radians. Those units are, in fact, canceling. The pi's cancel. Let's see. 12 goes into 180 15 times, so I get 15 degrees. And if you didn't notice that 12 went into 180 right off the bat, you've got a couple options. You can work it out as a long division problem, or you could just reduce a little bit at a time. Start with the fact that 2 goes into both of them. If 2 goes into both of them, I could say, okay, 2 goes into 12 6 times, and this goes in 90. It goes into 180 90 times. 2 goes into both of them again. Goes in 3 times, goes in 45 times. 3 goes into both of those, goes in once, goes in 15 times. Okay, so a number of different ways that you can reduce. No matter what, we get 15 degrees.